Yeah, thanks very much, Brett. I work in the storage and virtualization team at the University of Birmingham. Just a little bit about the university before we crack into the DataCore part. So there's around 200 people in IT services overall, and we provide services, applications, infrastructure for around 38,000 students and 6,500 staff. So we're a pretty decent sized university. We have the luxury of 2 IT data centres on our main campus. They're about a kilometre apart from each other, and we have some pretty decent links between the two. So we're able to run dual data centres. We have a reasonable sized VMware installation with over 950 VMs as of today, and around 58 hosts, actual physical servers that provide that infrastructure. And as with any big research-based university, we've got multiple petabytes of data spread around all over the place. But within our team, we look after around 1.5 petabytes of that. So a bit of background around the specific problem that the university had with regards to why we ended up with DataCore. One of the main cables that runs into our substation, which is just down the road, somebody decided to try and steal that, and in doing so they set fire to the substation, and that took us off the national grid for around 4 to 5 weeks. As well as affecting us, it affected around 20,000 homes, businesses, as well as the QE hospital, which is next door to us. So it was quite a big outage. During that time, we have the main data center, which is protected under a UPS, but we've never run it for 5 weeks on diesel. So there were issues with that. But also our second data center didn't have any UPS protection apart from in the racks themselves. So we were very exposed there. Some of our services, some of the core infrastructure elements weren't actually covered by UPS protection at all, so some of the networking, for example, and other bits and pieces. So we were really, during that period of time, we could get maybe 5 minutes notice that services were going down, and we had to start shutting down storage arrays, and this happened throughout the 5-week period. So it was quite a major incident for us. And as part of that, we had some services which were fully resilient. However, the actual failover process was quite a complicated one. So with our old storage arrays, it was a full manual failover process. So as part of this, the senior management team and the IT director spoke to the business, because obviously during that time a lot of services were lost, were going up and down during the day, which is not ideal for any institution. And the resilience initiative was set up, so a core management team within the resilience were set up to manage this project. They identified the top 20 services that were critical to the university's business, and their goal was to make those top 20 services fully resilient with no human intervention. So they wanted automatic resilience between the 2 data centers, whether it was between the 2 data centers or cloud or whatever, but they wanted it fully automatic without any intervention. So a team was set up. Each of those top 20 services was allocated a strand lead. Virtual infrastructure and storage was reasonably high priority within that. So I was nominated the strand lead for storage, because that's kind of my key role within the storage and virtualization team. And one of the main things was, as part of the project, that nothing was off the table. So any solution we put forward would be taken on board, and we'd put forward our top 3 options, if you like. And so that's where the project really kicked off. So from a storage perspective, we obviously looked at what the main requirements were going to be within that environment. So obviously the automated resilience, that was a given, that was specified by the project. But obviously from our perspective, we had everything else to do as well. So we needed something that was fast and easy to implement, that was as cost effective for the university as possible. Ideally, it would work with our existing storage, so we didn't have to buy extra capacity, because that would have been a big cost to to not only have to shift to a fully resilient system, but to also have to implement new storage capacity on top of that. Obviously, no performance hit. There's no point having resilient systems if they don't perform to the levels that the business require them to. And it must also support our VMware environment within our team. So they were sort of the key requirements from our perspective. So we began the selection process. We looked at solutions out there, Hitachi Metro Cluster EMC. You probably know what the solutions are that were out there. We're a HP house at the time, so HP EVAs, which didn't have any sort of solution, even though we were replicated in there. So we were looking at every vendor really to see what solutions were out there. The DataCore meeting was actually a bit by chance. So one of my teammates had an email and was getting hassled by the sales team for DataCore. And in the Monday meeting, we were talking about the resilience project, and he said, "Oh, hang on a minute! I've had an email from these guys called DataCore. They sound like a perfect fit for this project." So we got the guys in, had a meeting, sat down. It certainly sounded like a great product. So while we were looking at your EMCs and your HP3 parts, we were also looking at the other end, the software-defined end of the scale as well. And they filled us full of confidence and said, "Here's the installer." He says, we reckon you'll have it up and running in about 30 minutes. So we fired up some VMs, installed it within them, and we were able to present out resilient storage, pull the power out of those VMs, and the storage stayed online. And we just kind of liked it. It worked out of the box. It worked within 30 minutes. As I say, it did just work, and it's not often that actually happens in my experience in IT. So we put together a proposed architecture with DataCore. I hope you can all read this, because obviously there's some quite small writing on there, but the slides will be available after, I believe. So we have our existing storage fabric, which was resilient in itself between sites, between data center A and B, and also we have two storage fabrics. We had our existing HP EVA 8400s and 6400 arrays, which already plugged into that. We have a campus high-speed network and also a private network for management. So we were looking for something really that just fit into that environment as it was. So what we specified in the end was we were going to put in 2 servers, which were just standard off-the-shelf HP DL380s, I think. We put in some extra HBAs and then really just plugged them all into the fabric, into the networks, and it was an extremely easy process to go about presenting EVA storage directly into the DataCore nodes. The DataCore nodes you set to mirror each other, so when you create the LUNs, it just creates a LUN at each side and keeps it synchronously replicated. And it was a very, very easy process to actually get that up and running. So the architecture was we had EVAs at each site, SAN fabric at each site, network at each site, and a DataCore node at each site. So it really did just fit in with our current environment. So as I say, we were able to repurpose our HP EVA storage. We didn't actually have to go out and buy any more storage arrays. So it's quite a simple implementation for us. And as with any solution, we had to go to finance and justify why we wanted to do it. So we put forward 3 solutions, an EMC solution, HP solution, and the DataCore solution. And obviously the DataCore solution came out far cheaper. So we went ahead and purchased. So with regards to DataCore itself, we implemented it, and we kind of knew it was going to do its job before we went there, because we tested it. But actually, not only did it meet our requirements, but it exceeded them in a lot of areas. And so day to day now, I'm not sure how we'd live without it. So it's kind of we really, really like the product, as you can probably tell. So it's actually improved the performance of our VMs. So we've because of the RAM cache that's built into the servers. I don't know how much you guys know, but it uses RAM built into the servers to actually speed up storage, and it does some clever things with mirroring and that. And also because we've now been able to implement solid state storage, which we'll talk about a bit in a second, and we've got no cold data on expensive disks, so we've gone to an auto tier environment where we're getting the best performance out of our storage. The planned maintenance experience, so before DataCore, the idea of shutting down a data center filled us full of dread. It required major planning. Obviously the failover process required systems to be shut down, and then the replication to be failed over, and then systems to be brought back up. Whereas nowadays, if we need to take a node or a data center offline, no services have to be downed as part of that failover. So that's a real big win for us. We have 4 maintenance windows throughout the year, where we could potentially, the facilities team could potentially require data center shutdown or power saving while they test air conditioning and stuff. So now it's just migrate VM and shut down the DataCore nodes, shut down the storage arrays behind them. It's really simple for us. The management and support of storage in general has improved. So the actual day-to-day management of storage. So on the previous arrays, presenting a LUN was a really laborious task. Whereas with DataCore, you can create groups of hosts, groups of storage, and sort of present them together, and it's really drag and drop, dead easy, and it does just work. So it's made our lives a lot easier. As the guys said before, it's a single user interface, so once you've presented your storage into it from your storage arrays, or you've direct attached storage, whatever type of storage you want to use, it really does. It is really a single pane of glass, and straight ahead to provision storage. DataCore's technical support, so we had one experience of having to talk to them, and that was something that we did incorrectly. So just before you guys get worried about the how well the product actually performs, it was something that we actually did that took it offline, but we got onto DataCore technical support, 1 hour response, and they helped us out, and we got the service back up and running with next to no outage. So our experiences from that side have been really good as well, and we're not reliant on other vendors because we're mirrored between the 2 sites. If an array goes down at one site, we're still automatically running from the second site, so that really doesn't affect us anymore, and we only have that one immediate support channel. The rest we'll fix it as and when. It's lowered our storage costs on the whole, so we've actually looked at, we can run on auto tiering, so we've got much more capacity disk, and less sort of fiber channel disk. So when a service needed fiber channel disk previously, it would all sit on fiber channel. We didn't really have an easy way of saying, well, actually the database itself needs to be on high performance, but the OS and the OS and the backup drive might not need to be on high performing disk. DataCore actually sorts that out for us in the background. Improve visibility and utilization. So previously, we had multiple storage arrays with discrete management interfaces, so we didn't really have an overall view of our storage and the growth and reporting, so DataCore's given us that. Thin provisioning, it wasn't supported on our previous storage arrays until a very late code upgrade, and there wasn't really, once we'd implemented it, there was no real way of actually going back and implementing it on the existing storage. So it's the amount we've saved through just thin provisioning alone has been quite impressive. Stuff like the seamless migration between back-end storage, so we've actually swapped out our back-end storage arrays since we've had DataCore installed, and with no downtime, so you migrate one site at a time between storage arrays in the back-end. It's dead easy, dead straightforward, so that saves us loads of time. Hardware vendor tie-in, so we could have EMC arrays, HP arrays, Dell arrays, it doesn't matter in the background. DataCore works with all of them that we've tried. They've got their hardware compatibility list, so we're just presenting storage in, works really well. So again, it gives us the freedom to buy the right storage solution for what we need to achieve instead of what the vendor wants to sell us. So that's great. And as a result at the university, so we obviously initially looked at the top 20 services as part of that resilience project. That's been a real success. We've actually had real world failures of data centers and outages where we've had to shut down data centers in their entirety. So we've proved it works in real failover scenarios and planned failover scenarios. Been 100% impressed with it. So now the policy is, the default policy is that all VMs that are production and can't be made resilient within the application will sit on. So we think that infrastructure resilience isn't a fix for application resilience. We think that if an application can be resilient, like Exchange or Active Directory, that should be should still stay discrete and be distributed across campus. But for anything that can't easily be made resilient, we put it on DataCore and it's protected. So we've got over 500 VMs on there on our DataCore 2 nodes at the moment. So we've migrated from our tier 1 storage arrays down to mid-tier arrays, and as a result we've been able to put in solid state, SAS and nearline with the auto tiering, but we've done it at a much more affordable cost. Solid state disks for our tier 1 storage arrays are extremely expensive, but for mid-tier arrays it becomes much more affordable. So we actually we run on some mid-tier arrays, auto tiering between the different types of disk, and it runs really, really well. And we're currently in the process of expanding our environment from the 2 nodes to the 4 nodes to give us even more resilience within the environment, and also to provide some extra capacity as we grow into the future. So it's certainly a solution that we're still investing in at the moment, which is really great. So I suppose in summary, it really has made our lives easy. I mean, I'm always skeptical when salespeople talk to you and tell you how great something is, but for us, it's made our lives so much easier, and it's been perfect, the perfect fit to our specific issues around providing resilient systems, and we look to expand on it in the future.